bioanalytical technique that I will describe is ELISA, and that stands for Enzyme-Linked Immunosorbent Assay. But first, let's understand what all these words mean. So, immunosorbent relates to techniques making use of the reaction between antibodies and antigens. Two important parts of the antibody are the two binding sites at the top for antigens and the base containing a binding site for communications with components of the immune system. Assays measure the amount, presence, or activity of a target, typically with a plate or cuvettes in a spectrophotometer. Overall, ELISAs measure amounts or presence of certain antibodies in a sample. Let's make a quick overview. The first step is to attach antigens to a surface. The next step is to add a specific antibody with an enzyme linked to it to the sample. Finally, we will add the substrate for the enzyme. The enzyme catalyzes a reaction of the substrate, which causes a color change to be visible. So overall, solutions with a greater amount of enzyme-bound complexes produce a greater color change. The way we can quantify this is by plotting optical density after the color change by concentration. We can plot a known set of standards and produce a standard curve. We can then use an unknown sample's optical density in the standard equation, calculating the concentration of our unknown sample. There are three different types of ELISAs: direct, sandwich, and competitive. Before we can get into the specifics of these, we need to review a couple vocab words first. The first word is primary antibody, which is simply an antibody that binds directly to an antigen or protein. The next word is secondary antibody. These bind to other primary antibodies, which are then bound directly to antigens or proteins. Now that we have established some vocab, we can look at the different types of ELISAs, starting with direct ELISA. The first step is to coat our plate with an antigen. Then we will add a primary antibody with an attached enzyme. We can then add our substrate where the enzyme will catalyze a reaction, causing a color change. The advantages of a direct ELISA is that you can use it in tandem with something like a Western blot, and this can actually tend to be cheaper than some of the other ELISA techniques. Where there are advantages, there are also disadvantages. In your sample, you'll have antigens, antibodies, proteins, and many other substances along with your antigen. Any molecule from your sample could bind to the bottom of the plate, creating competition for space. At this point, the instrument might not even pick up your specific sample. Also, you want the enzyme-linked antibody you add to bind only to the antigen you're interested in. This can be a disadvantage because finding an enzyme-linked primary antibody specific to your antigen can be expensive. Overall, direct ELISAs are most commonly used to determine ideal concentration or dilutions for primary antibodies to be used in other experiments, like Western blot. The next technique we'll look at is a sandwich ELISA. Here you begin by coating your plate with a known concentration of antibody. Your sample containing antigen is then added on top, and the antigen binds to the antibody. The specific antibody that you're interested in looking at levels of is then added to the plate and binds to its specific antigen. Next, an enzyme-linked secondary antibody is added. Finally, the substrate of the enzyme will be added. The enzyme will catalyze a reaction, causing a color change in the solution. The advantages of a sandwich ELISA is the ability to detect low or unknown concentrations because of the very specific reaction between antibody and antigens. The ability to use a generic enzyme-linked secondary antibody makes it cheaper than a direct ELISA. The big disadvantage to sandwich ELISAs is that you can only use monoclonal antibodies, meaning they come from the same immune cell. Otherwise, the antibody-antibody binding won't occur. Monoclonal antibodies can be hard to find and expensive. The final technique to look at are competitive ELISAs. You begin by incubating unlabeled antibodies with your sample of antigens. While the antigen and antibodies are binding, you are also going to coat a plate with the same antigen. You'll then add the bound mixture to the plate, where any unbound antibodies will bind to the antigens on the plate. Next, it's important to wash the plate to rid of any extra complexes that aren't bound to the plate. Finally, an enzyme-linked secondary antibody can be added and the substrate enzyme reaction can occur. The main idea for this type of ELISA is that the more antigen you have in a sample, the more antigen-antibody complexes will form, so less unbound antibodies are able to bind on the plate well. This is competition. More competition leads to a weaker signal. The advantages of this type of ELISA is that it doesn't require matched antibodies like the sandwich ELISA. You don't have to use a secondary antibody either. Also, the primary antibody that you do use does not have to be purified. The disadvantages to this type is that if you don't use a secondary antibody, you have to find a protein that the primary antibody recognizes. This can be difficult. Now let's go over some things to remember. When you first coat your plate with antigen or antibody, not every molecule will bind to the well. The residual molecules in solution can give false positive readings, so it's important to wash the plate between steps with a mild detergent. You may wonder why those antigens or antibodies bound to the plate are not washed away also, and that's because when we coat the plates in the first step, they're incubated with enough time to form charged interactions to adhere them to the plate walls. Another problem to solve is that you want to prevent residual molecules from binding to empty spaces on the well that aren't bound by your antibody or antigen. A blocking agent is often added, which prevents background interference by binding non-reactive proteins to available space on the well. Let's take a look at an overview of the pros and cons of ELISAs. ELISAs are relatively quick and convenient, but the fast reactions mean that the microplates must be read immediately after reactions occur. Antigens in low concentrations can be detected, which is very unique, and reagents typically have a very long shelf life. Some antibodies, though, are hard to find, and that can be expensive. So what's my opinion? I think that ELISAs are a staple. However, because there's much room for error, it should be used in tandem with other bioanalytical techniques.